So with number one, I got interrupted, so I'm just not going to write it all over again. But the idea is we want to make sure that the y is by itself. So we're going to subtract the 3x over, and so that's how I'm getting the 3 minus 3x. And then I'm going to take that 3x here, and I'm going to put it in the y spot in the first equation. And so you'll notice that I put it in parentheses because there was a minus sign or a negative in front, and I want to distribute that negative to everything. So I'm going to go x squared and then minus 8x. All of that just comes from your original equation. And then it's minus, and instead of writing y, we're plugging in what we just got, which was 3 minus 3x. And so then we distribute the negative 1, and we get negative 3, and we get positive 3x. And now we're going to combine like terms. So we've got negative 8x plus 3x, which is negative 5x. And then we have negative 3 plus 7, which is 4. And so now you're at a quadratic in standard form. And so from here, you should be good in saying, okay, we're just going to factor. So 1 times 4 is 4. And we're looking for factors of 4, so 1 and 4 or 2 and 2. And we're looking for factors that are going to give us a negative 5. And the only way we can get negative 5 is if both of these are negative. And because it's a 1, we're going to factor the fast way and just say this is x minus 1 and this is x minus 4. And then we're going to set those equal to 0 and solve. So we have x minus 1 equals 0, x minus 4 equals 0. And then we're going to solve that by adding 1 to both sides and by adding 4 to both sides. And then to find the y, we have to take these two solutions. So we're going to take the 1 and the 4, and we're going to take those and we're going to plug it back up here into the y equals 3 minus 3x. And so you'll notice if I put 1 in that equation, so if I do it the first time, my y1 I'm going to have is 3 minus 3 times 1. So this is 3 minus 3, which is 0. If I do the second point, then I'm putting in 4. So I'm going to go 3 minus 3 times 4, which is 3 minus 12, which is negative 9. And so then my solutions are going to be 1, and because that's the x1, basically that's our first point, and the y that goes with it is 0. And then our second point, which is our 4, is going to be 4 and then negative 9. And these are my two solutions. Okay, so then when I look at problem 2, I can do one of two ways as well. I can do substitution or elimination. If I do substitution, I always like to do substitution if I can. I think it's easier. I'm going to subtract the 3x. So I'm going to get y is equal to 2 minus 3x. And then I'm going to take this value and I'm going to plug it in where the y goes. So again, it's going to be 4x squared minus 13x. And because there's a minus sign, I'm going to do minus 3, and I'm going to put the 2 minus 3x in that spot. And I'm going to distribute that negative 3. So it's going to go 4x squared minus 13x. Negative 3 times 2 is negative 6. Negative 3 times negative 3x is positive 9x. Minus 2 equals 0. And then we've got combined like terms. So we have negative 13 plus 9, so negative 4. And then negative 6 and negative 2 is negative 8. And then because 4 divides into all of them, that's always your first step, is take out greatest common factor if you can. And because we have an equal sign, I can just go divide by 4, and it just goes away. Like I don't have to worry about hanging on to it anymore. So I've got x squared minus 1x minus 2 equals 0. And then we're back to where we were before, which is we're going to go 1 times negative 2 is negative 2. Factors of 2 are 1 and 2. The way I'm going to get a negative 1 here is my bigger number is my negative. Because a is 1, then I can just write it quickly as x plus 1 and x minus 2. So then I'm going to go x plus 1 equals 0, x minus 2 equals 0, and we're going to solve from there. So we're going to go subtract 1, we get x equals -1, add 2, we get x equals 2. And again, we're going to take these two solutions and we're going to take them all the way back to the top where we solved for y and plug them in. And so we're going to do y1 is 2 minus 3, and we're going to plug in the first point, which is -1. So we have 2 plus 3, which is 5. And then if we do y2, we're going to use 0.2, which is 2, and we're going to go 2 minus 3 times 2. So 2 minus 6, so we have -4. So then my solutions are -1, 5, that's my first point, and 2, -4, that's my second point. All right, and then we saw question 3, which was kind of bad. So we're going to kind of pretend that didn't happen. Or we can pretend that it happened if our numbers were nicer. It's not that anything, like, it's not horrible. It's just we end up with a fraction that's kind of not pretty. So I'm going to skip 3. Let's go to 4. If I was doing number 4, remember that because I've got x squareds lined up, y's lined up, the x lined up and the constant lined up, I could just combine these two by either adding or subtracting, which is the elimination method. So because it's a positive y and a negative y, I can just add them together. So I'm going 1 plus 1, which is 2, x squared. And then this is 1 plus -1, which makes that go away. 1 plus -3 is -2x. And 12 plus -8 is +4. And then I either can divide by 2 first or move them all to the same side. So if we move them to the same side, we have got 2x squared plus 2x minus 4 equals 0. And so basically I just added 2x to both sides and subtracted 4. All right, so when you say, like, what happened? That's what I did. And then I'm going to divide everything by 2. This is going to give me x squared plus x minus 2 equals 0. And now we're back to that same idea. We're looking for factors of -2, so 1 and 2. But this time I want a +1, and so that makes the smaller one be our negative. And so we've got x minus 1, and we have x plus 2. If we set each of them equal to 0, and we solve, we're going to go add 1, so x equals 1, and then subtract 2, so x equals -2. So these are my two x solutions. And then I have to determine which equation I want to plug it into. It's not quite as nice because we don't have one solved for y. So I just have to choose which one I'm going to plug it into. So I'm going to plug it into the top. And so my first one I'm going to plug in is the 1. So I'm going to go 1 squared plus y equals 1 plus 12. And so we get 1 plus y is equal to 13. And then we're going to subtract 1. So y is equal to 12. And then, so that's our first value of y. And then the second value of y, we're going to do it, we're going to put the -2 in. So I'm going to go -2 squared plus y is equal to -2 plus 12. -2 squared is 4. -2 plus 12 is 10. And then we're going to subtract 4 from both sides. And so we get y is equal to 6. So then our solutions are going to be 1, 12, and -2, 6. And this is what our answers would be. All right. I'm going to go back to 3. If this would have been a plus, so we're going to pretend that it is a plus just so we can make this work out semi-better. In this case, I would still do elimination because I liked that my y's were above each other. What I would do is either change everybody's sign on the bottom or I would subtract, and it's kind of up to you. So if I do x squared minus x squared, I get 0. If I do negative y minus negative y, I get 0. If I do 5 minus negative 2, I get 7. And 1 minus 1, I get 0. And I just want to go through it with the 0. So this is 7x is equal to 0. We divide by 7. So we get x is equal to 0. So we only get 1 point. If, again, this is an if, that was a plus. If it wasn't a plus, you saw it on the board, we got negative 2 sevens, which wasn't beautiful. All right, so we're going to take that. We're going to plug it in up here to one of the equations, and we're going to go 0 squared minus y equals 5 times 0 plus 1. And so that we don't worry about. So negative y is equal to, that we don't worry about, 1. So then we divide both sides by negative 1, and we get y is equal to negative 1. So it would say that these two u's, or quadratics, would intersect at the point 0, negative 1. If, again, if we change that to a plus. If we didn't change it to a plus, what we got on the board was it was negative 2 sevenths and 25/49. It wasn't beautiful. It wasn't even close to being beautiful. All right. So if we change the problem, we get this answer. And that's what I was hoping for. All right. So when we look at the next little part, we are looking for adding. Okay. So we're going to add or subtract or multiply. And the key part is we have to have the same number of elements in each matrix in order to add or subtract. Okay, so when I look at this, my answer is going to go in a matrix. All right, and we're going to just go negative 6 plus 5 is negative 1. 4 plus negative 5 is negative 1. Okay, and notice that those are both going in that top row. Then we do the next row, and we're going to go negative 5 plus negative 5 is negative 10. Still same position. And then we've got 6 plus 3, which is 9. And then our last little bit, we've got 2 plus negative 1 is 1. Negative 5 plus 0 is negative 5. And that's my answer. If I was doing number 6, the very first thing you're going to do is multiply because you have these numbers out. So what happens is it gives you the matrix negative 10 if I just distribute the 2 to everything. Okay, we get negative 10, negative 12, 6, negative 2. And then for the second one, that's going to be kind of up to you. I like to distribute the negative so that I can just add the matrices together. It's totally up to you. It's just easier for me. So I'm going to go negative 4 times negative 5 is 20. Negative 4 times 2 is negative 8. Negative 4 times negative 1 is 4. Negative 4 times 6 is negative 24. And now we've got 2 matrices with 4 columns, and we're just going to add the pieces together. So I'm going to go negative 10 plus 20, which is 10. I'm going to go negative 12 plus negative 8, which is negative 20. I'm going to go 6 plus 4, which is 10. And then we're going to go negative 2 plus negative 24, which is negative 26. And that's my answer. And then our last one is just multiplying by a scalar. We're just going to multiply that by everything. So we've got negative 30, negative 30, negative 10. And that's my answer. Number 8, same thing. You're going to give the 3 on the outside to every element on the inside. Actually, I'm going to stop here and do this on the second video.